Hello everyone and welcome to Moonshot Contemplations. Each week we invite a special guest to help us broaden our horizon and introduce us to new ideas on how we can use frontier technologies and access to new domains to build a bigger and better world. We then host a second session for our diverse collection of members to engage in deeper discussions, and hopefully some of them will find new inspiration. That's some of you. So from founders to investors and researchers, from space infrastructure to manufacturing and biomedicine, from robotics to data analytics and AI. Space is all encompassing. So today we're joined by the founder of Being Systems, Kieran Blair. And Kieran's also a fighter pilot and instructor for the Royal Australian Air Force. And he's using his valuable experience in airworthiness frameworks to design a spaceworthiness framework to help guide the emerging Australian space sector. Interestingly, Kieran's also working on an exciting project at Being Systems to provide industry and researchers with simulated microgravity for testing and development of space infrastructure. So Kieran, thanks so much for joining us. Have I missed anything?
No worries, mate. No, that's pretty much the two things we're really focusing on at the moment. It's good.
Yeah, great. So we'll dive right in. Tell us a bit about your background. A lot of people would be really interested to hear from a fighter pilot who's now interested in space.
Yeah, I mean, I've got it's an aerospace background really. So started my career with the Defence Force, went through uni with them with the dream to become a fighter pilot. It's just a process of steps and a lot of training and focus you go through. Ended up flying jets for about 5 years, which has been really awesome. And then stepped into some testing evaluation roles. And now I'm learning to teach, well, teaching people to learn. Which is another really awesome part of my career that I've been able to be involved in. It's actually super useful skill to have.
Yeah, how have you found that process of learning how to teach? I know from my experience, it's not easy. People think it's intuitive, and it really isn't.
No, it's definitely an art, right? And I find the better I know the students and the trainees that I'm working with, the better we can actually work together to learn. So. It's not a set way of doing things, but it's an incredible thing to do, to be honest. I've been thinking about it the last week. That's why I say that. It's just learning how to learn is one of my the things I love to do. So being able to help people learn how to learn is awesome as well.
Yeah, very much. Here. I'm all for that. So why space then? Is this something are you looking to switch? Are you looking to switch from air or aero to space, or do you want to keep the two together? What's the relationship between the two for you?
Yeah, I mean it's aerospace, so it's a very logical progression from aviation and the systems and the techniques and methods that are used in that being able to be applied to space, aerospace. So a lot of the methods of aviation with regard to redundancy and risk management and human physiology are all completely applicable in space. So from my career perspective and building on my skills and interests, going from flying and aviation to aerospace makes a lot of sense. It's also a really interesting field that's starting to expand quite quickly. So there's a lot of value, I think, that can be transferred across from the aviation industry to help people in the aerospace industry. I think there's a significant amount of value there that we can avoid reinventing the wheel and use instead. And that's why I'm here. It's the next step, really. It's exploration, really. Test your skills and go try new stuff out.
That's fantastic. And I think that idea of not reinventing the wheel when we don't have to is kind of novel at the moment, at least here in Australia. I think a lot of people, and including government organizations, feel that space is has been this intangible thing, and so everything must be built again from first principles. Whereas that's not actually the case, is it?
No,
we do have frameworks.
100%. People think space is this new sector. Actually, we've spoken about before. It's not so much a new sector. It's like saying Earth is a new sector. Things exist on Earth. Things are going to exist in space. So it's not a sector as such. It's kind of a encompassing environment, let's call it. But a lot of that stuff that we do on Earth is directly applicable. It's just understanding what space is and how it's going to be used in the future, which is an industry we can build, can then drive our thinking and research and education into what we're actually going to do. So From that point of view, it's really, I found a lot of research and reading has evolved my thinking into understanding what we can actually do in space and what we have already done that we can do in space or can be used in space. And I think that's where expansion should probably start. It's a good place to start anyway.
Can you give us a little bit of a summary of some of your learning there, and I guess point some of our viewers to places that they can look at if they're interested to understand what does space have to offer for us today?
Yeah, I mean, I've been looking at it purely from an aviation perspective and looking at the systems and developments and technologies that have been created in aviation and the underlying themes of those and how they're applicable in space, because most of them are. A really easy one to understand is human physiology. Go out flying a fighter jet, you're pulling 7 to 9G, and it has all these unique effects on your body. Or in 0G, it has some significant unique effects on your body. So the research that's been done in human physiology and aviation medicine the next step of that is space medicine, which is exactly what's happening. So that's one environment. Another way I've been approaching it is from a redundancy. So aviation is inherently risk adverse, not so much adverse, but it contemplates a lot more risk than, say, a business would. There's a lot more what ifs and for what's going on. So that risk management framework in aviation is directly applicable to many things that we can use in space. Space is pretty harsh. It's not exactly forgiving. So reducing the risks that we have in space, say for people, is something we've done before and is directly transferable across. There's no change in process there. I reckon they'll actually evolve together. And from that point of view, like the whole idea of evolving together is where I'm looking at it from. It's like, what can we evolve using the environments of space that can then benefit, say, things on Earth? Human physiology is one of those that we're working with and looking at the moment. And we're pretty much, I'm just running through the aviation themes and then seeing what can change or what space going to improve upon that's usable down on Earth. I think there's a lot to come from that, actually.
Yeah, totally. So one of the questions I have is, I guess we're both Aussies, we're both in Australia, and we've got this emerging space sector, and everything is quite new to us here. But obviously, in Europe and the US and China and other places, space flight is something that's been happening for a little while. What lessons can we learn, and what lessons can they learn as well, in this new era of space? Do they need to look at developing new space worthiness frameworks? Is it easy for us to just take a carbon copy of that and apply it here? How do you think that should happen?
From space worthiness, I guess space worthiness is designed from the concept of airworthiness, which is, if I summarize it, it's the safe and effective use of anything in the air. So how you go about testing that or evaluating and validating that those parameters, whatever you set, can be met is the process of airworthiness. And that's quite robust and in depth. Obviously in space, it's not quite there yet. NASA does it pretty well. They've built off aerospace. The ESA does it quite well. All the space agencies that are developed do it well. But from a commercial point of view, I don't think it's really been explored too much yet. There's large commercial companies out there like SpaceX, Space Adventures, and sending things into space that have to do it. But from a commercial point of view, I don't think many people understand it. And I think that's important because it's actually a path to space. It's a path to getting in the air. You have to go through airworthiness to be able to be airworthy. So if we think about it that way, you can see spaceworthiness as a path to being space-worthy for things that are, say, going to be in space. So the ability to be space-worthy or even understand what that is as a framework can guide and hopefully reduce a lot of reworking or overwork that's been done for people who want to launch things into space, or even just understand how systems work in space. So that's kind of the whole idea of space worthiness that we're looking at. And then finding the directly applicable and first kind of projects that are going to use that is where the Australian industry comes into it, or, the global industry comes into it, really.
Yeah.
So that's how I've been viewing spaceworthiness.
So what are your thoughts about, so this is, I guess, some topical news then, with the news that Tom Cruise is going to be shipped up to the ISS to record a movie. And there's a lot of, I guess, there's a lot of people within the space community that are torn on this. I personally think it's a fantastic thing from the perspective of space communication and outreach and that kind of thing. But there's a lot of people concerned that that it's irresponsible to put what some people describe as a civilian, just a non-traditional astronaut onto the International Space Station for non-critical reasons. Having dealt with a lot of flight worthiness and thinking about space worthiness a lot, what are your thoughts about sending casual people onto something like the International Space Station?
I think of purely from a technical point of view, it's a risk management exercise. So it'll be the same as sending any other astronaut up, I'd imagine. I don't know, but there's assessments that need to be done on Tom Cruise, and the standard assessments that need to be done on a spaceship going to space. So I think those processes would be the same. So from that point of view, it's completely fine. It's just a process. I guess one of the things that those people who object to it would be looking at is from a resource perspective. We only have a certain amount of people or weight or whatever that we can send into space. So is it a great use of space launch capability to get Tom Cruise into space? I don't know. It depends what they're doing it for. But it also verges into that whole idea of NASA's new space industry, right? It's trying to use space from a commercial application. From that point of view, I get it quite. I understand what they're trying to do, in that it's a new use of space for a commercial application. That makes a lot of sense.
Which I personally think is great.
Yeah,
but I understand the flip side as well. Yeah.
Yeah, I mean, everybody has resistance to change, right? You've got to try stuff for it to figure out if it's actually going to work. Maybe sending one person for a movie is actually a good idea, because it'll sample what's to come. But I mean, if you think about tourists in space, that's one of the largest parts of the new space sector that is opening up. Like Richard Branson's launching passenger flights. He's got 600 people already signed up for it and prepaid to put on his commercial space launch vehicle. That's a part of it. Maybe NASA's just trying to get in on the action. I'd actually be pretty interested to hear more about what they're trying to do with that.
Me too, and I'm quite interested in. I feel like what we'll find out eventually is that there will be a lot more commercial involvement in actually having this happen. I don't think it's going to be NASA themselves will facilitate a lot of this project, especially given the recent pushes over the last decade or so, to have a much more commercial presence in space, so for NASA to sort of take other roles. What are your thoughts about, I guess, the role between private industry or even public industry, but industry and government in this new emerging space sector with regards to space worthiness? And also enabling, what should we be enabling the use of space for? What kind of applications and how can we do that better?
Well, I mean, if we go back to our NASA, Tom Cruise and thought experiment, it's if NASA's trying to increase the amount of commercial events, whatever, in space, it has to get out of the way, being the only person getting into space. So that would assume some sort of framework capability to foster a commercial use of space. That's very different from what NASA's been doing previously, but it's also very similar to what a government should be doing, not should, but can be doing in industry. So from that point of view, let's use that as a framework. It's like, how can government provide the right framework for commercial industry to enter space, which is a question I'm assuming they've been addressing for a while. I mean, Australia's got its priorities out about what it wants to do in space. They're limited and they're not all encompassing, which I guess moves us to the space worthiness question is, what are the other ways that can foster the ability for people to use space? And that's where I see spaceworthiness as. It is a path to space. It's something people can use as a direction, as a compass, to develop their technologies, to develop their products, to find out the specifications and what they need to meet before they can actually get there. And it wouldn't be limited to just, say, sending something into space. It's a framework for understanding systems in space, for designing things on Earth. Another way I've thought about it, which we've spoken about, is space is a really challenging environment, right? So to be able to be challenged and have a set restriction on what you can do requires you to innovate what you currently have to make it work in that environment. Space is the alternate means of doing that. And I came by that by looking at aviation, because aviation is the exact same. It's like, how do you fly from Sydney to New York? It requires a significant amount of technological change, innovation in the way that we're doing things, changing methods. Space is going to be exactly the same, except 10 times worse. It's 10 times more inhospitable than aviation. So if you've got a means, a spaceworthiness means, to look at that environment and then design things for Earth in that environment, you're kind of fostering and innovating in doing just what you're doing. That's not easy, obviously.
No,
so
much easier said than done. It sounds great. Yeah. So you can do this tomorrow, right?
Yeah, the caveat is you're restricting yourself from making your life easy, which is a good thing, but it's also not the greatest means to be commercially viable, but that's a challenge, and innovation's always had that challenge. So finding better ways to do things is always difficult.
Yeah, and I guess that's one of the challenges that we're seeing, particularly in Australia at the moment, but also other places around the world, is that we know that there's a lot of opportunities for the use of space infrastructure. We know there's a lot of opportunities for space enabling businesses and commercial ventures to better enable new space infrastructure. And on the other side of that, for space enabled applications from data and analytics and space medicine and all these kinds of different areas as well. But space is hard. And we've got governments that are trying to cherry pick, look at what is our strength, what should we focus on, and that risks cutting certain other, entrepreneurial pursuits out of certain equations. What are your thoughts about this? What should we be doing, and how do we encourage more people to collaborate and be entrepreneurial and try to do these difficult space-related ventures?
Yeah, I mean, a top-down look at things in that a government, outlining its priorities of what it wants to do is great, but it's going to be restrictive in its design. It has to be. So I guess the inverse of that is the bottom-up design. How do you enable a bottom-up method of doing things, but select the right processes and the most value-adding infrastructure, say, to enable that? And there's a real crossover there between what the government's enabling from a top-down perspective and what people are trying to do up from a bottom-up perspective. Who's got the best view of what's the right thing to do, or the most value-adding thing to do? They're two completely different perspectives, and that's a problem. People from the bottom up are engaged and willing to use their time, their effort, that sweat equity, let's call it, and design new things. But if they're not enabled to do it, that's not going to go far. But that's a good thing and a bad thing as well. Bad ideas probably shouldn't go that far. So the government's got a really hard role, but founders and people designing space infrastructure or space technology also have a really important role in validating their ideas and making sure that what they're actually going to do is not just a fun project, though they work out sometimes as well, but is actually adding value to whoever they're trying to sell it to or make it for or enable. And there's I think help there. So Moonshot's a perfect example. They get help doing that from mentors, from people who understand the industry. So it's an interesting crossover between a bottom up and a top up process in a new industry that might be resource restricted, let's say, but not personnel restricted, because lots of people want to get involved. It's not a balance. It's it's a push. It's, you know, you have to make things happen. So you will find ways to do things.
Yeah. What's my train of thought? Yeah, and I guess on that, what, you know, when people are trying to think about, you know, well, you know, I really want to get into the space industry. I feel like, particularly in Australia, there's probably a lot of people that have had these great careers in manufacturing, say, you know, the automotive industries, that have these amazing, you know, skill sets and experiences, but not necessarily any further career path they can pursue there. So they might be looking at, you know, opportunities in space where we, you know, might be able to create new areas of, you know, advanced manufacturing or robotics, these kinds of things. What advice would you have for people that are looking, you know, or potentially looking at this point in time to say, all right, I want to find an idea or a problem to solve, you know, and to work out, you know, how do I build a business model to build something related to space?
I mean, there's so many ways to answer that question, and, you know, my answers aren't going to be right.
I left it a nebulous question on purpose. Yeah.
I mean, the old adage is find a problem and fix it, right? Somebody has to want what you're creating, or want to create, or, you know, design from your own problems. I think advanced manufacturing has a problem in that it's very hard to access space. So from that point of view, you should find that you should be looking at evaluating your ideas on what's actually feasible and possible at that time. You know, if you want to 3D print something in space, it's like, all right, well, how are you going to get to space to see if it works? You know, your problem is access to space. It's not 3D printing things in space. So, you know, determine
what are the things,
what industry you're actually in.
Yeah, for sure. One of the things that you and I have spoken about a lot is, and I guess this relates heavily to our Moonshot space elevator framework, you know, the different stages of how we can help increase the sophistication of, you know, individuals that have ideas all the way to having a successful global space business. And as a part of that, obviously, there's, you know, there's the business side of things, but there's also the technology and technology readiness and testing, validation, and having these a pathway and stepping stones to increasingly, you know, improve your technology readiness level. What facilities are available to us here on Earth? You know, I'm sort of, you know, I'm throwing you in a particular direction with regards to, you know, you're talking about creating microgravity simulation environments. So how can people, what facilities are out there for people to be able to use, so, you know, so they don't have to necessarily access space to test a particular idea out, and to have that sandbox?
I guess there's multiple types of facilities and how you use them. From a purely physical point of view, you know, there's pressure, there's temperature, there's acoustics, there's vibration. All these facilities exist mostly in universities in Australia. You know, there's, like we said, we're developing the microgravity, where you can actually go throw things around in microgravity or on Mars or in lunar environments, that's being developed at the moment. But from an engineering and a technical point of view, there's also systems and environments for predicting how things are going to operate as well. They're probably the better way to do things, but, you know, their fidelity is quite low. Well, some of them are low, some of them are very good. So from an infrastructure point of view, Australia is limited, but not as limited as we would think. Access to those things is limited, and we're not NASA, right? NASA have billions of dollars worth of equipment that they've purchased and invested in over time that's become available. And I think that in the States, that will become more available in their commercial new space type arrangement. So they're the kind of facilities that are available. Think environments. It's like, sweet, I need to be floating around. It's going to be cold. There's going to be no pressure, and there's going to be some significant radiation and space weather rolling around. These are the environments that I have to exist in. Where are they, and where can I test them? Radiation's a bit of a problem. Obviously, it's very, very difficult, if at all possible, to simulate space radiation. You kind of have to be in space because it's so varied and unpredictable. But, you know, the temperature and pressure stuff is there. The microgravity stuff's on its way. Something we're looking at is combining them. So how do you get temperature, pressure, and microgravity all at the same time to increase the fidelity of your testing? You know, how do you use those? Is back to the spaceworthiness point. It's like, when do you want to use them? They're also quite expensive, you know. These things don't come for free. So what value are they actually adding, and what value are you getting out of them? Is it going to be worth it for you? But yeah, they're there, definitely. Just have to, I suppose, not ask the right people, do a bit of research, figure it out. And, you know, Moonshot's a great place to start for finding out what's available there. And even just talking to other people who've used them before.
Yeah. I guess how much reliance do you think that, you know, these emerging industries should have or do have, you know, on space agencies? Whether it's, you know, if you're in the US, you know, do you think that industry there might be too, you know, startups in particular, too reliant on NASA? In Australia, I feel like there's, you know, a very heavy reliance on the Australian Space Agency, where we probably don't need to worry too much about what they're doing at this stage, at least anyway. You know, we can sort of get on with it and do what we need to do. What are your thoughts around that?
I always ask the question, whose rules am I playing by, right? So the space agency is doing an incredible job, and like, hats off to them. They're an incredible point of call for people. Unfortunately, they probably need a few more people and they'll all run off their feet. But, you know, the guys we've spoken to there are doing an amazing job. I think the issue that we're kind of dancing around is a bit, the space agency is small, but the space industry is small. So as a point of call, it's kind of the only place, or the most dominant place we have, right? You can't go talk to one of Australia's primes about, hey, I've got this idea in space. They're like, cool, we've got our own as well, and we're doing those. So nice to meet you.
No go away.
Well, yeah, we just don't have any interest. You know, we're doing our own things. So it's a bit of a desolate kind of landscape. But it's, you know, it's not without opportunity by any means. You just have to create it yourself. So the space agency I see as a touch point at the moment. They do a very good job of bringing people together to develop the capabilities in accordance with the government, which is their job. But again, whose rules are we playing by? Where else can we find these people that are also in the sectors that we're in? Where do they exist? I'm cautious to say only in Australia. You know, that Australia is a very small economy compared to the globe. There are a lot of other people doing large things overseas. Do we have a touch point for those? Not really, that I can find. You have to seek them out yourself, but that's a good thing as well. So yeah, that's where I'm seeing that the space agency sits at the moment. But the community, I mean, you're probably a better person to talk about the community than I am. In, you know, where is that coming together well? Where's the gravity bringing people together around certain ideas or concepts or themes that actually add value? And is it actually happening?
Yeah, well, I think it is. I think there's still tweaks that need to be made. You know, obviously, I'm quite biased because I've built up a company, you know, Moonshot, to do exactly that in a way that I've sort of, you know, I feel like, you know, there's a lot of discussions happening that we could be a little bit more efficient in doing, facilitating. But overall, I think we're doing quite well. I guess I'm interested to hear about how you started being systems. You know, you're quite early still in your journey, but, you know, where did you get the inspiration from to start it? What is it? And tell us about, you know, the microgravity flights. How do, like, we might need to explain as well what is microgravity, and how do we simulate it here on Earth, or on Earth in the air?
Yeah, we'll start with that one. What it is. So microgravity, there's no such thing as zero gravity. There's always some sort of gravitational force acting on you. It's just, what size is it? The whole idea of microgravity is floating around in space. You see the astronauts floating around, they're in microgravity. They're just, the gravity that's affecting them is Earth's gravity. They're just falling so fast that it never catches up with the ground. So they're just falling the whole time. So, I mean, if we take the theme of falling, that's it. So there's things called drop towers, where you can put a small experiment into a container and then drop it from 300 feet high, and it experiences microgravity as it falls. the other thing you can do, which is what we're doing, as most people know, is called the vomit comet. So you take an aircraft and you pitch the nose quite high, about 45 degrees nose up, and then you can match the acceleration of Earth's gravity by flying the aircraft. It creates kind of like an arc, a parabolic arc. So they're called parabolic flights. And that creates gravity environments in the, or relative to the aircraft. So you can get 0G, you can get negative G, you can get Mars gravity 0.38, you can get lunar gravity 0.17. You can simulate all these environments.
For the layperson, would you potentially describe it? It's kind of like an extended turbulent jump, if you're in an aircraft, right? Where you're like, suddenly you're just like, whoa, I'm dropping.
Yeah, well,
is that kind of what people would experience?
Well, if you've been in an elevator before and it starts to drop when you start going down, that's less than 1G. So, that elevator's going down. It's the same concept with an aircraft. You're pushing it down. And therefore your weight is relatively reduced. So if you've ever felt that jump, in an aircraft for turbulence where you've lost your tummy, or in an elevator, that's a change in gravity you can simulate in an aircraft. And gravity's gravity, so it's applicable across everything.
Cool. So you're gonna get an airplane, you're gonna fly it relatively high pitch, and you're gonna bring it back down. And you're going to simulate microgravity. Tell us about that. What kind of technology you need? What aeroplane is this? Can you give us information on that?
Yeah, it's a private jet effectively. So if you think, a Learjet, as people would call it. So it's a Learjet. It's fast. It's maneuverable. And that's kind of what you need. You need acceleration. So. That's what we're looking to use at the moment. So we're just going through the systems of that, because if you think about it, an aircraft systems exist in Earth's gravity. They're very different in space, and now you're going to create that environment. So you have to modify the systems such that they operate there. So that's the kind of aircraft we're using at the moment. And the other question, I suppose, is how do you operate in that aircraft? So thankfully, we've got a background in aviation, so we understand what we need to do with regard to taking dangerous goods and the regulations and the legislation behind what the safety requirements are in that aircraft to do that. There's some regulatory hurdles there. But if you bring all those together, what you get is the ability to test anything with fluids, temperature, pressure in a contained environment. In a contained aircraft that's creating microgravity. So that's what we're creative. It spans across, doesn't span across sectors. It kind of spans across elements, pressure, temperature, radiation, and microgravity. So everything that fits in there or wants to be in there can be tested, provided it's small enough, meter by meter in an aircraft. And that's what we're looking to do.
That's great. So I guess what kind of applications, like who would the customers be for a service like this? And I'm really interested. For those who are familiar with the vomit comet, what do they use, like a Boeing 747 or something? It's quite a large plane. So how does this is quite novel for a country like Australia to be able to have this microgravity capability. Could you dive into that a little bit as well and just explain why this is so important, and what sort of, I guess, products and industries that might not necessarily consider themselves as a space company might want to look at using this service?
Yeah, I mean, it's a niche capability that it's not new though, right? So this has been done, like you said, by the Vomit Comet, which is an old USAF 707, I think. They've done a lot of, very simply, it's astronaut training. So they've done a lot of astronaut training. That's a good place to start. But all the things that go along with astronauts and their physiology, their health, also are required to be tested. And there's a significant branch of medicine within Australia at the moment looking at biomedicine in space. So that's something that we're focusing on and working with those organizations to develop those programs. They're directly applicable back to Earth. A lot of people have probably heard about the physiology, how it changes in space. If your bones become less dense, say, it's like, what can we use to make them more dense in space, which creates medicines for people's bones who are, say, atrophying on Earth. And so that's a very simplistic understanding of how it can be used back on Earth. And the other one's kind of easiest to understand is look and see. It's like, I'm going to put this thing in space because I have no idea what's going to happen when it is in space. So that's your bulk standard testing and evaluation. And there's tons of applications across that. We've seen universities in Australia go overseas to test the deployment of their solar panels on their cube satellites, say. There's been development of space drinking bottles or space beers as well. It's like, how do you fluid doesn't flow without gravity, so how are you going to pour your
enjoy
beer
your bev when you're on? Yeah.
So simple applications like that. So that's just from a microgravity point of view, right? And that's kind of the easiest way to understand it. There's going to be experts in fields that we don't even know about that have understandings of how that works as well. I consulted with a NEMS or MEMS, microelectronic mechanics or something along those lines. It's like, right, we build we build these very small actuators on the ground under 1G, but they're so small that as soon as you take away that gravity, it morphs, it changes. So it's like, we don't even know if that's going to work in space, so we have to test it somewhere.
Interesting.
Yeah, with and then there's a manufacturing one like you spoke about. There's a few tests going on in manufacturing. I think it's made in space in the US, which went on the ISS, and they're developing really high quality fiber optic cables, and they're pulling them in space due to the lack of gravity. Before there's less inconsistencies in the material and higher bandwidth or higher rate of exchange in the material. So that's another application. Really, it's kind of niche at the moment, to be honest. I think there's a lot in this industry that's going to change. I think there's a lot of applications that we don't know are applications yet because it's so new. That's kind of the three or four things that I look at the moment as the big ones coming.
So what does the, I guess for you, what does the business model look like it's going to be at the moment? It's interesting, we're in, like we mentioned earlier, Australia's quite a small market. We've got a lot of, neighbors around us. Asia Pacific region is an emerging space. There's a great emerging space economy there. What does the market look like for you in this?
It very much looks like continuing projects that we can help, and bookings for people who need help understanding what's going to happen in space, and we can provide those environments. I think the most value that we can add is in the programs. It's an ongoing research type program looking at specific things. And I think it's very useful because you can also build on those processes for other people to use in the method of, say, spaceworthiness. So, biomedical programs, that's been going on for a while. We're looking to start a few of those up. And then once we get a foothold in there, it's like, all right, we've got a certain amount of people looking to do things. Where's the next value add from there? Who else can we help? Is it mining? Is it, who's moving into space that may need help? So it's definitely along the lines of long-term projects in research and development or physiology. And then, taking bookings and helping people out with their one-offs kind of as well. And I think it'll be around for a while. I think that there is a yet to be realized demand in the industry due to the lack of understanding of what space is. I think that the actual onus is on us to spread that education of what's actually possible, which is some great stuff that Moonshot does. So,
thank you. I guess, in case there's people out there, and I hope that there are people out there watching this, getting ideas, Australia's got this great platform through what you're doing at Being Systems with this microgravity, the ability to have these microgravity experiments and these, these small sandboxes to cheaply and easily and locally being able to test whether something can actually function in space. How can they engage with you? How should they get in touch with you? And what kind of, are there any specific kinds of, niche vertical areas of applications that you're particularly interested in the near term?
Yeah, I mean, we've just got our website, really. We're working closely with people mostly as we set up operations, beingsystems.com. You can go there. There's a form down the bottom or an email address that you can get us on as well. in terms of applications that we're looking to work on, you know, we're working mostly with physiology at the moment, human medicine. So there is a community there already that if people want some sort of connections into, that we can help out with as well. You know, it really depends on what they're trying to do. If they're looking for microgravity, that's it, you know, or Mars or lunar gravity. That's who we're out here to help. And you know, we've got contacts with all the other environments as well. So if we can build that community around the problems that people are trying to solve, and you know, if they can contact us and we can contact other people, that would be fantastic. That's how you can get a hold of us.
That's great. So before we wrap up, I want to ask you, you know, how would you define space in the modern era?
I tend to go philosophical, right?
Go for it. I love philosophical.
It's I came up with a question a little while ago. It's, you know, what are we going to do when we've explored the galaxy already? It's just like, well, okay, well, there's no answer to that question. It's not been done yet, but it invokes a lot of other questions. You know, who are we going to be? What technologies are we going to have to be able to even do that? So space to me doesn't so much mean advancement. It means understanding. You know, we exist on Earth. Earth is just a lump of rock floating around the solar system in the universe amongst many other universes, right? So it's that understanding of where we actually are. And I'm attracted to space because it doesn't lie. If it doesn't work, it doesn't work. So, you know, it's a really great testing ground as well for ideas. And then you add that philosophical kind of layer on it. It's almost comes under the encapsulating kind of word of exploration. You're exploring things. You're finding out what's what, you know, as close to real or reality as you can get. And space presents the questions that allow us to explore that, but also the environment to test ourselves going into that. So that's where I look at space from. It's human growth, really.
Yep, that resonates pretty well with me. I won't go on about it right now, but yeah, I totally agree with all of that. So, Kieran, thank you so much for joining us today. This has been absolutely fantastic to have a chat with you. We always have these great phone conversations, so it's really good to be able to open that up to let more people engage with that. I'm looking forward to having more of a discussion with everybody on Tuesday next week. Hopefully you can join us. We're going to have a number of Zoom rooms or we'll break out, and we can have people from, you know, investors to more founders to people of, you know, all different backgrounds and academic backgrounds, discussing some of the things that we discussed today. And like I said earlier, hopefully some of you will be inspired to start looking into how you can participate in this emerging space sector. So Kieran, thank you very much for joining us for Moonshot Contemplations, and I'll see you again soon.
Yeah, no worries. Hopefully you got something out of it, everyone. Okay.
Cheers.
See you, mate.